message. That's fine, because everything is asynchronous. We're just sending messages if we want to. In this case, we send a reply. And if it's not a string or an integer, we're actually going to terminate the entire program. Serious piece of nastiness. And I hope that I've got my punctuation correct here. Almost everybody in the UK and America will know this term because it was made famous in Fawlty Towers. There were only ever 12 episodes, but I think Ke is said some 400 and odd times in that. Have a look at Fawlty Towers, it's hilarious. Okay, so we've got a couple of classes. That's all we've done so far. What can we do with it? Well, let's instantiate one of these classes and start it. So we've created an instance of an actor and we've told it, run your act method. Be active. So we create a provider and we pass a reference to this transformer and go, get on with it. So we've got these two actors sitting there doing nothing. The synchronization is inherent in processing messages. That's where the synchronization is. So they just sit there doing nothing. And then we send in a message to one of them. And then we send in and wait for a response. So we require a reply here. What's dangerous about this? Deadlock. So just because we're using these models doesn't mean we're immune from deadlock and live lock. It means it's more controllable. It's more obvious where things are going to be. It's in your face. We know that in actors, messaging is asynchronous. So here is our blocking wait. And this will be a theme throughout sensible use of parallelism, and in particular GPars. If you need to wait, you have a blocking wait. You know where the synchronization is happening. We'll see this when futures, when Java, well, Java already has futures. If we're using those sort of things, it's exactly the same model. So we send 14 in as a message, and we await the reply, which is going to be provided here. And you can probably guess this says hello world. I hopefully set that up. Right, and you're thinking, way too much code. This is Groovy, for goodness sake. I mean, Groovy's supposed to be lightweight and thin and not Java-like. So let's actually do it a bit properer. Whoops. So it's exactly the same code. It results in exactly the same actor system. But instead of explicitly defining classes, we're going to use these factory methods. So we have a factory method for a reactor. So this is a stateless system that replies. So a special form of actor that just has a closure to define what the reply system is. Here we have a more general actor, and the act method is written for us, in effect. So we get the builder is actually building up the code. Nicer? Yeah, I think so. This is the way it would be done, I think. Same effect. We ship in a word, we do a send and wait, so the actual script is fundamentally the same. It's just the way in which we construct these actors is very much the same. So if I go up, no, I don't need to go up, it's just there. You've all got GPars installed. You might not have the GPars documentation installed. It doesn't come with the Groovy bundle. But it's all online. You find it somewhere. This is the user guide. So some quick references on the side here. So if we have a look at the actor quick reference, there's some stuff here on the concepts of actors, which is what I've just gone through in the last 15 minutes. What's the life cycle of an actor? And you've got some examples of various different life cycles. And what we've got here in the actual chapter is yet another version of Hello World, done in yet another way. So have none of this only one way of doing things. There's always many ways of doing things, but you're always looking for the factory method. What's the loop that we're going to run? What's the closure we're going to execute? Actually, probably need to size that up a bit to be able to see what we've got here. This one's just sending a message of some sort into a decryptor. So this is one instance of an actor. Here's another instance of an actor. It's the same loop react. This is just a one-shot react. So when you pass something in, this will get executed. Passes a message here, which I'm never a great fan of message instance of string, but there we go. You can stop these things. So you have got control flows going there. But there's the reply, and we're reversing the message, prints it out. What are these joins? Well, sometimes you actually have to manage your thread pool. Underneath all this, I say, threads are infrastructure. They are there because they are what the JVM uses to map down to the kernel threads and thence to our cores. And what we're seeing here is that if you actually want to let this run to completion, you actually have an extra thread, which is the main thread coming down here. So there's the main thread and the thread pool for the actors. So it's very similar to using swing and AWT, if anybody actually still does that in this HTML5 universe of ours. But as soon as you start with swing, you get a second thread. And if you start doing swingish things on the main thread, all hell breaks loose. But you eventually have to halt the main thread and say, wait for the swing stuff to finish. And really that's what's going on here. We've got an actor, they're independent, there's a thread pool managing them, but we've got the main thread still going on down here. So we have to wait, and so we're using the join on the threads. So sometimes these thread things do percolate through. We try and minimize them as much as possible. So you're wanting to do some coding. You want to try some actors. Yes, I know you do. So what we should do is set ourselves a problem. And you've got to have some form of example. And so I'm thinking of Sleeping Barber. Many reasons, because there are a number of examples out there in the universe, almost all of which are wrong. One of which has a reasonable reason for existence, and the ones that you are going to write are going to be really good, because you're going to use GPars. The problem statement, and afterwards, when people start programming, I'll put this back up so that people can see the rules, as it were, of what's going on. But let me use this diagram to try and exemplify those rules. The Sleeping Barber as a simulation problem is people arrive, so you have some sort of arrival function, sounds like a waiting thing, and when they arrive they look into the barber shop and they see if the barber is doing anything. If the barber's not cutting hair, he or she is asleep in the chair. So you wake the person up and get a haircut. If the person is being cut already, then you see if there's a waiting space. So these are waiting seats. Think queue. So if there's space in here, you join the queue. So fixed length queue. Good model for that. Barber looks like an actor. It's receiving messages. Messages coming in. Messages as people coming in. And when they're cut, they leave. And so you think, the immediate reaction is go look on Wikipedia. Yeah? That's the first thing most people do. So you go and look on Wikipedia and you'll see that there's a Sleeping Barber problem. And have a read of it. It's very good. It's the Dijkstra specification of it. When was Dijkstra doing these toy problems? 1960s. What was the context? Operating system. The actual thing behind this is how do we manage processes in an operating system? But I much prefer this as a toy model of how do we program this with actors. So we've got a shop actor that's managing this data structure. We've got a barber actor. So we want people to arrive in the shop and for the shop to manage them. And when the barber's ready, send people to the barber to be modelled. Are you getting a feeling for how you might program this? Do you want to go and experiment? Do you feel you have enough tools to have a go? Or are there some questions you want to ask to delve more deeply into this? The reason I'm trying to elicit a response is because I don't know how much you are interested in experimentation research and how much you like answers given to you on a plate. So we've got a few people voting for experimentation. For those people who like your answers on a plate, hitch yourself on to a person who likes to experiment and work with them and do some pair programming and find out about how, whoops, sorry, let's take this one later. Find out about how you might set up an actor to do this, how you might set up an actor to do this. Let's give ourselves 15 minutes to have a play and a look. I've pointed you at the documentation. Yes? You reckon you can find it? Sorry? That's embarrassing.